This problem is pretty different, mainly because of these plus signs right here, and the trick to doing a problem like this is a common denominator among each and every one of these fractions. So I need to look at this 9x, this 3x squared, this 3, and this x, and try to find the LCD of those four things. So I hope everyone understands that, like, I'm going to look at the coefficients separately first. I need to find something that 3 and 9 goes into evenly. The smallest thing possible that they all go into is 9. And then, of course, I need something big enough so that I could divide it by x or divide it by x squared. And that would mean that I would need to have, of course, an x squared. The LCD is going to be 9x squared. If you're still not 100% clear on why I'm picking 9x squared versus a 9x, watch what happens as I go through this, and you'll totally understand why it's got to be that way. Because we need to pick something that'll make this entire thing cancel out. It'll make this whole thing cancel out. You know, all those denominators will have to cancel out, and this is definitely going to do all that. So the very next thing I'm going to do, now that I found out the LCD is 9x squared, is multiply the top, the numerator, and the denominator by 9x squared. Now that's not how it's going to look when I actually do the calculation, but I want to point out why we're allowed to do that. We can do that because, as you all know, if you multiply something by 1, it doesn't change the value. As you also know, if I divide something by itself, it equals 1. So if I take this entire fraction and multiply the top and the bottom by 9x squared, I'm essentially not changing the value at all because I'm basically multiplying by 1. Now this is what I'm doing, but if you think about what would happen next, this 9x squared, were I to multiply it by this numerator, it would distribute to each part of this, and this would also distribute to each part of this. So the way I actually write it when I do it is going to look a little bit different, and you'll see that right after I pause this video and erase some stuff and rewrite some things. So 1 second here. What I would actually write down is this times 9x squared, this times 9x squared, this times 9x squared, and this times 9x squared. And now some things are going to cross cancel, and the whole point is that these denominators, this one, this one, this one, this one, they're all going to cancel away. For example, these 9's will cross cancel, and this x will cancel one of these x's. So I'll be left with simply a 4x when I do that calculation. When I do this 3 will cancel, this x squared will cancel this x squared. But when this 3 cancels, there'll still be 3 left behind here. So this will become plus 4 times 3. For this part, this 3 will cancel. This will be a 3. And I'll have 3 times x squared times 2 to give me 6x squared. And then for this part over here, this x will knock out one of these x's, and I'll be left with an 18x. Maybe I should show that cross cancellation for everything. On this part over here, this 9 knocked out this 9. This x knocked out one of these x's. I was left with that 4x. And for this 3 knocked out part of this 9. This x squared got knocked out completely, and I had 4 times 3 was 12. So what I end up with is 4x plus 12 over 6x squared plus 18x. And there is some cleanup I can see here. Like, for example, off the bat, I can see that everything is an even coefficient. So I can start off by dividing everybody by 2. If I can do it to everybody, I should. If I can't do it to everybody, I can't do it to anybody. But these are all divisible by 2. And the second thing I notice is that we have some more common factors here. Like, for example, this has a common factor of 2. So that could be 2 times x plus 3. And this has a common factor of 3x. So that if I pull a 3x out, I'm left with an x plus 3. And then I notice finally that these are a common factor on the top and the bottom. They'll both cancel. And the final answer will be 2 over 3x. Now I am aware of how crazy all of this looked. So what I want to just kind of reemphasize, if you're good at finding that LCD, if you can look at these 4 denominators and know that 9x squared is going to be the thing to use, then the trick is to just to use that cross cancellation 4 separate times to make those denominators disappear. And as soon as those denominators disappear, you should start to be able to read a little bit easier. You know, it's just a matter of recognizing that, like I said before, like these 9's will cancel, this x knocks out one of these x's, and just kind of take it piece by piece by piece by piece. Make sure you're understanding what you're doing as you go, and it won't be so bad at all.